The next Thevenin and Norton theorem cases is when we have a circuit that contain an independent source and also contain the dependent source. Okay, so for these cases, so the first step is we need to remove the load terminal and sketch the circuit. And then the second one, we need to determine the voltage open circuit or Thevenin. And then the third step is we need to determine the RTH or the RN. Okay, and then we need to sketch the Thevenin and Norton equivalent. So for this one, we have two methods to find the RTH. Okay, so the method one to find the R equivalent, R Thevenin and R Norton is you need to find the V open circuit and you need to find the I short circuit to find the RTH. Okay, so to find the VOC and ISC, so we follow the same procedure given before. And to find the RTH is equal to VTH divided by IN or V open circuit divided by I short circuit. Okay, for the second method, to find the R Thevenin or R Norton, okay, we use the V test or I test. Okay, for the Thevenin, we turn off all independent source and then we apply a V test source at any value. For example, we use a 1 volt at the terminal AB. This is the terminal load. And then you compute the current I naught, which is this is a I total, and then you can find the R Thevenin by equal to the V test, which is 1 volt here divided by I naught, the current total I. So for the Norton, you need to turn off all independent source and then you apply a I test, which is you can use your I test is equal to 1 ampere at the terminal AB. This is the load terminal. And then you need to compute the voltage across this terminal AB and you can find the RTH by equal to the V naught, the compute voltage divided by I test, which is here is 1 ampere. This is example 4.4 where we want to sketch the Thevenin equivalent circuit based on the given circuit. Okay, so here this is terminal A and B, which is this is the load terminal. Okay, and then in this circuit we have independent source and also we have the dependent source. In order to find the RTH, you can use either this is the method one where you find the RTH by using the VTH divided by I short circuit, or this is a V open circuit divided by I short circuit, or you find the second method is RTH by using the V test divided by I naught. So this will be your I naught, this will be your IV, 1V, which is a V test. Okay, so this is method 1 to find the R equivalent where we find the V open circuit first and the I short circuit. Okay, so from this circuit, we need to find the V naught first. So at this V naught, we can find the KCL. Okay, where V naught minus 6 divided by 5 minus 1.5 Ix plus Ix equal to 0. Where you can get this V naught minus 6 divided by 5 minus 1 over 2 Ix equal to 0. So from here, your Ix is equal to V naught divided by 3 plus 7 because this is in series. Okay, so you divide by plus 4. Okay, so you can substitute this Ix into this equation. You get your V naught divided by 5 minus 1 over 2 V naught divided by 7 equal to 6 over 5. So you substitute, you simplify this equation, you record your V naught is equal to 9.3333 volt. Okay, so now we have our V naught is equal to 9.3333. Now we want to find this VTH. Okay, we can use a voltage division. Okay, your VTH is equivalent to 4 divided by 4 plus 3 times by V naught, which is 933. Okay, then this value you will get your VTH is equal to 5.3333 volt. Okay, and then we need to find I short circuit. Okay, so in order to find I short circuit, this terminal A and B, you need to do a short circuit. So now, this is your new circuit. Okay, we have this short circuit. This is your IN. This is your I short circuit. For this circuit, you see that the 4 ohm is parallel with the short circuit, which means you can ignore this 4 ohm. Okay, and now we want to find this V at this node first. So I put this as a V1. So your V1 minus 6 divided by 5 minus 1.5 Ix. So your Ix is here plus Ix is equal to 0. Then you will get your V1 minus 1 over 2 Ix equal to 6 over 5. So from here, you can see that your Ix is equal to V1 divided by 3. Okay, so just substitute your Ix. You will get V1 divided by 5. 1 over 2 Ix is V1 over 3 equal to 6 over 5. So you will simplify this. You will get your V1 is equal to 36 volt. Okay, and then you can find your ISC, which is your ISC is equal to V1 divided by 3 is equal to this 36 divided by 3 is equal to 12 ampere. So now you can find your RTH is equivalent to V short circuit divided by I, V open circuit divided by I short circuit, which is equal to 5.3333 divided by 12. You will get your RTH is equivalent to 0.44 ohm. Okay, so this is a method to where we want to find our RTH, R Thevenin, by using a V test equal to 1. Okay, so in order to use this method, you need to turn off all the independent source by short circuit the voltage source and open circuit the current source. So this circuit is the equivalent circuit after all the independent source being turned off. Okay, so now we want to find the current here, I note here. Okay, so first we find this V1 and this is your V2 by using a nodal analysis. Okay, so find the KCL at node 1. We get V1 divided by 5 minus 1.5 Ix. So this is your 1.5 Ix plus Ix is equal to 0. Okay, so from here, you will know your Ix is actually equal to V1 minus V2 divided by 3. And your V2 here is actually equal to 1. Okay, so you can use V1 minus 1 divided by 3. Okay, so now if you simplify this circuit, you will get your V1 is equal to minus 5 volt. Okay, and then at this node 2, KCL at node 2, okay, you will get this negative Ix plus V2 divided by 4 minus I naught, which is this is your I naught at this direction is equal to 0. Okay, and then you will get your I naught is equal to negative Ix plus V2 divided by 4. So your Ix is actually equal to V1 minus 1 divided by 3. So we have a minus here plus V2 is actually equal to 1 divided by 4. Okay, so here we also get our V1 is equal to negative 5. So negative 5 minus 1 divided by 3 plus 1 over 4. You will get your I naught is equal to 2.25 ampere. Okay, so now since we know our V test here is equal to 1, so your RTH is equal to V test divided by this I naught. So this is I test, this is I naught. So your V test is equal to 1, your I naught is equal to 2.25 ampere. You will get your RTH equal to 0.4444 ohms.